Hello, welcome to the channel. We are continuing our integration series, and today we have an indefinite integral of arc cosine of x dx. Well, before diving in it, there is a playlist which contains all of the videos of this topic, namely integration by parts, and the link for it you can find in the description down below. Alright, we'll use the following approach. We can write this integral as an integral of arc cosine of x times 1 dx, right? And then apply integration by parts. That's the whole idea of this integral. So we'll use integration by parts in the following way. We have u is equal to arc cosine of x, and dv is equal then to 1 times dx. Now then, du is just minus 1 over square root of 1 minus x squared, and v can be found easily, it's just x. Alright, well here this is a table value that you need to remember. For arc sine of x it was just 1 over square root of 1 minus x squared, and for arc cosine of x is with a minus. So what we want to obtain here is u times v minus an integral of v times du, and putting all values together we have x times arc cosine of x minus an integral of x times minus, well, instead of minus here I directly write plus here, so it's x times 1 over 1 minus x squared with the square root dx. Now let's rewrite the expression quickly. It's arc cosine of x plus just x dx over square root of 1 minus x squared. Now at this point I want to make a quick remark that of course we'll calculate this integral now in a usual way with substitution, which comes naturally to our minds, but if you're attentive enough you can spot that we have in the denominator we have square root of 1 minus x squared, whereas in the numerator there is x times dx. Well, the pattern here is that we know that, let me write it quickly, square root of y, its derivative will be 1 over 2 times square root of y. Now in our case we have form of 1 minus x squared in the square root, so let's write it down. We have 1 minus y squared, and see what happens when we compute the derivative of this expression. We have 1 over, again, 2 times square root of 1 minus y squared times, since this is a composite function, we need to multiply it by the derivative of what's inside. It's a chain rule. So derivative of what's inside is 1 minus y squared, so it's basically minus 2 times y. Now multiplying these two we get y over, well, minus y over 1 square root of 1 minus y squared, and this is pretty much exactly the same that we have here, except with a sign of plus. So if we have plus minus here, then we would have plus here, right? Because it's just like constant, multiplying this by minus 1 resolve this. Like if you multiply here, we would need to multiply it by here, so we'll have plus. So I hope you got the logic. It's not a necessity that you must do this in your minds in this way, but this kind of a common integral, and in this way you can save lots of time and also see the patterns that can suddenly appear. Alright, now in a traditional way we would just apply substitution, and the one that most of you would write is just y is equal to 1 minus x squared, right? Because that's what we have inside a square function. Let's compute dy, which is minus 2 times x dx, and for brevity I prefer writing like x times dx, it will be minus dy over 2. Alright, I think that's enough. So we have x times arc cosine of x plus an integral of, well, x times dx is minus dy over 2 times, now 1 over square root of y. Now it equals to, again, x times arc cosine of x minus 1 over 2 integral of dy over square root of y. Now this integral is like just an integral of y to the power of 1 minus 1 over 2, right? And it's done in a standard way. It's 1 minus 1 over 2 times y to the power of 1, like minus 1 over 2 plus 1 over minus 1 over 2 plus 1. And it's, well, we have some constant here, but I'll write it towards the end. It's x times arc cosine of x minus 1 over 2 times y to the power of 1 over 2 over 1 over 2. It's just x times arc cosine of x minus, now these two, they cancel out each other because it just means we have 2 here, and we also have square root of y, so it's just minus square root of y with a constant, but I'll write it towards the end since we need to replace y by its initial value. We made a substitution. It's 1 minus x squared. So the final answer will be of the form x times arc cosine of x minus square root of 1 minus x squared and plus some constant c. It's the constant that we added here, here, and here. Okay, I'll rectangle it again without any AI. Here's our final answer. If you have some questions, you can just write them in the comment section below. A quick note on what we did is just noting that there is one here, hidden one, and applying integration by parts. And when you see this integral, you can either think a little more and derive this integral from the scratch, or just go in a standard way and by hand just calculate what it is using substitution, which is indeed time consuming, but that is the cost for being standard, perhaps. Alright, see you on the next videos. Bye.